Hello, my name is Paul Brooks of VIAVI Solutions. Today I'm going to give a presentation on preparing the way for 800 gig ZR. This presentation was originally shared for the market focusing session of ECOC 2023. 800 gig ZR is the next stage in pluggable coherent optics. The OAF has laid down a very strong agreement which gives us a solid baseline to allow the module vendors and coherent DSP vendors to start meaningful development to bring products to market. The first 800 gig coherent DSPs for pluggables started emerging in mid-2023, and early alpha sample of optics are expected in Q4 of calendar year 23. 800 gig ZR and also other outreaches such as LR coherent optics, they're significantly more complex than classic 800 gig client optics. Client optics are typically based on IMDD, intensity modulated direct detect, whereas coherent modules, of course, by their very nature, are coherent and require a lot more DSP complexity. This leads to greater power and cooling requirements from the host. The module management and control, performance monitoring, is significantly more advanced and more complex. And the traffic required, we need frame traffic. So, the coherent DSP has to frame and map traffic. So we need 800 gig Ethernet, for example, as both 800 gig ETC, and of course, as part of the IEEE 802.df emerging standard. Coherent optics have evolved a long way over the past couple of years. And today, we can see that has delivered to us pluggable coherent optics, but let's trace that journey. Many, many years ago, coherent optics were engineered high-performance systems. They were from a single vendor, a closed ecosystem based on high-performance custom ASICs and optics. This gave very, very good performance, was optimized and focused on DWDM transport. But of course, being a closed ecosystem, it didn't often always offer the price and scaling needed. But over the past couple of years, based on standards and multiple vendors offering coherent DSP and other things, we now see a very healthy multi-vendor ecosystem. The parts now available from multiple vendors for 400 gig have allowed a very healthy and vibrant ecosystem with a lot of innovation and lots of flexibility based on the standards ZR, ZR Plus, and Open ROADM that can interoperate together and allow vendors to shop around for the most effective part for their application. And of course, being pluggable, these can fit in existing client equipment and doesn't need to be custom optimized as traditional engineered DWDM links used to be. Of course, there's a bit more demanding on the power and cooling and the management, but the standard plug gives people a lot more flexibility. So this established multi-vendor ecosystem for 400 gig is very solid now. Organizations such as the OAF, working with support from VIAVI, have shown multi-vendor 400 gig ZR, ZR Plus, and Open ROADM interop. This was again publicly demoed at the recent ECOC 2023. Development underway for 800 gigs as well. Let's take a dive into an 800 gig ZR module. And this really is a physics masterclass. Every area of physics is addressed here. High-speed electronics, going through that very small paddle card. For 800 gig, we're going to have 8 lanes of 112 gig SERDES, which is very, very stressful in terms of signal integrity and reliability. So lots of electrical engineering, signal integrity there. We have complex coherent DSP, with a PAM4 interface on the host side and on the line side. Complex coherent modulation. We have photonics, including tunable lasers and an integrated phase and quadrature sensitive optical receivers, all integrated at a very high level and closely coupled to the coherent DSP. So photonics, electrical engineering, mechanical, getting all of these parts to be integrated into a very small form factor. Today, we have 400 gig in a QSF PDD. Initial 800 gigs might be in the OSFP 800 form factor, but we will see 800 gig integrated down into QSF PDD 800 also. And this is also mechanically very challenging. Thermally, the coherent DSP tends to be more power hungry than classic client optics. So modules, of 20, 25 watts are likely at the early stages of 800 gig, perhaps even as high as 30 watts initially. But as those processes mature and people improve their firmware, we can expect the power envelope to come down. But still, we expect modules for 800 gig to be in the 25 watt region over time. So all these areas, electronic signal integrity, complex algorithm software, high integrating photonics, thermal and mechanical issues all need to be addressed to bring a successful 800 gig coherent module to market. So what are the challenges the industry faces to bring 800 gig ZR products to market? Well, they're in multiple domains, so multiple domain test visibility integration is critical. So let's look at these challenges and how they come together. So the first challenge, of course, is power. With 800 gig today, we expect early modules to be very close to 30 watts. This means we have to supply that 30 watts and also cool the 30 watts. So the host system must provide that 3.3 volts at 30 watts in a very stable, very, very high power integrity manner. It needs to be managed and controlled very, very carefully, precision. And of course, it needs to be very stable, but also the end user may want to margin it slightly higher, 3.4, slightly lower, 3.2. MSAs declare what voltage span should be supported. And of course, the module must be stable over those voltage spans. Cooling, thermal loading and stability is critical. The coherent DSP generates a lot of heat, but the photonics, things like the tunable lasers, are very, very sensitive. So they need to be carefully thermal managed. So it's very important the host testing has the ability to dissipate that 30 watts of power and hold those critical optical components like the tunable lasers to the thermal envelope. The host interface at 112 gig, that's a very, very challenging speed, each lane running at 112 PAM4. So very high degree of signal integrity, but also understanding when errors occur, what's the root cause. So deep insight into the errors, not just counting bit errors, which bit errors always occur on PAM4 signals, but having the true fingerprint of those errors is critical because you need to debug the SERDES and tune the host interface, make sure equalizers and voltage swings are set correctly to give a reliable interface before you launch that signal on the optical side over tens of kilometers. The optical modules, they are replacing a complete line card integrated into a small module. Lots of management must go over that I2C interface. Standards including CMOS allow a great deal of structure around the module management and bring up, but there's still a huge amount of care must be taken in managing, controlling, and reading data off these modules. The firmware to support that in 800 gig ZR is very, very challenging. And ultimately, that 800 gig ZR module needs to be very closely integrated with the host and management side. So through that management side, you need full visibility of each domain, from the photonic, the SERDES, the traffic, the PHY domain. All those need to be closely monitored and coupled to the host via that module firmware and management interface. Alarms and errors are also key. Being a coherent system, there's going to be lots of things that can happen on the line side, including classic optical issues, loss of signal, OSNR degradation, all the other things that are very, very important. So these key parameters must be quickly and accurately reported up through that host management interface. And of course, for a test and measurement and validation side, the ability to inject, manipulate, and track those impairments and inject them and then correctly see they're reported inside the complex DSP through the firmware stack, well, that's going to be key to a product that's stable, reliable, and works well with its host. Application Select has been one of the big success stories through CMOS, and really it's the way of a module advertising its abilities. Modern coherent optics, and this includes what 800 can do as well, can support a wide variety of modes. Here we see a module advertising what it can support for 400 gig. This includes multiple modes, both supporting 400 gig and 100 gig clients, and a very wide range of line sides, including open ROADM, ZR+, and standard ZR support. The module can advertise these things. The end user can read off via the CMOS firmware the different abilities the module is advertising, and it can make sure we get very close alignment between what the module supports and what the host interface is requesting. And this, again, helps immeasurably in the usefulness and integration of the host and module, because ultimately the end user wants the coherent optical module to act at one with the host and the capabilities and performance closely matched. Today, modules can advertise up to 15 applications, but even for some emerging coherent modules, that is not enough. So later versions of CMOS will expand that to allow many, many more modes to be supported seamlessly and tightly integrated into the host. 800 gig ZR, test and development. Well, this is where VIAVI really shines. VIAVI has had experience from the very early 100 gig days of pluggable coherent optics, and we've supported the coherent DSP vendors, the module vendors, and the system integration in the end users from the earliest 100 gig days up through 100 gig, 400 gig, and now at 800 gig. We understand the needs, the flexible support for different form factors, the wide range of traffic from unframed through Ethernet and ready for DF of IEEE. Ethernet broken down into multiple rates, including 8 by 100 gig or even 2 by 400 gig. Deep analysis of alarms and errors, both generation and analysis. Ability to control and manipulate transponders through the I2C, understanding the CMOS, and all the tools to make sure everything's working correctly, including automation. So whether you're developing DSP or developing optical modules, validating them or integrating them into hosts or even an end user, the applications supported by the VIAVI ONT are critical to help you accelerate your process and bring your products successfully to market. Everything from the earliest days of DSP development through to manufacturing test and scaling deployment. The challenges of 800 gig cannot be met in isolation with distinct themes. Even though there's an electrical domain, an optical domain, a management control domain, a protocol domain, they're actually very, very closely interlocked. The photonic domain impacts the coherent DSP, it impacts what happens on the PHY side, the protocol, and of course the firmware and the host control. So applications that are meaningful in troubleshooting and developing and validating ZR optics must be multi-domain aware. Test solutions must truly cover photons, firmware, SERDES, and PHY to get the full visibility to allow you to fully understand and debug issues. VIAVI offers all your coherent module development needs at 800 gig. We led the innovation from 100 and 400 gig with our unique applications. We've extended and enhanced those to meet the new challenges of 800 gig ZR. Thank you for your attention. If you want to find out more about this very exciting subject, please visit viavisolutions.com. Thank you very much.